Hello! On these notes we're going to look at how do we use the remainder and factor theorems. And the things that we're going to focus on are the division of polynomials using long division and synthetic division from Algebra 2. And then we're going to talk about what is the remainder theorem, what is the factor theorem. Alright, let's get started. Alright, the first thing that we're going to do is use long division to factor polynomials. So here we have 6x cubed minus 25x squared plus 18x plus 9, and we're given that x minus 3 is a factor. Alright, so long division works exactly the same way that it did in 4th grade, right? We set it up the same way, and now what we're trying to figure out is how many times does x minus 3 go into 6x cubed? So what would you have to multiply x by to get 6x cubed? Well, you'd multiply it by 6x squared. So I'm going to write that right above the other squared term. And now all of this gets multiplied by 6x squared. So I get 6x cubed minus 18x squared. And then remember that we have to subtract these. And whenever we subtract, these things I prefer just to change the signs and add. So now I'll get negative 7x squared. And you're always going to want to eliminate that term. And so again, just like old long division, we're going to pull down the next term, so plus 18x. So keep going. X to turn it into negative 7x squared, you'd have to multiply by negative 7x. So multiply both of those things, negative 7x squared plus 21x, change the signs and add, and we're at negative 3x plus 9. Alright, so just keep going through the same steps. So you multiply that by negative 3, we get negative 3x plus 9, change the signs and add, and everything goes to 0. Alright, so let's think about what we just did. We showed that this polynomial divided by this binomial gave us this polynomial. And what that means is x minus 3 times 6x squared minus 7x minus 3 is equal to 6x cubed minus 25x squared plus 18x plus 9. And now I can continue factoring this because this part's factorable. That factors down, well, so we'll keep the x minus 3, and then 6x squared minus 7x minus 3 factors down to 2x minus 3 times 3x plus 1. So now I've completely factored this polynomial using long division. And they're all my factors. One thing to be on the lookout for is if you have a polynomial that skips over some of the degrees of x. So like if I were to set this problem up, I would have 3x plus 2 on the outside, and then on the inside I'd have to have 9x cubed plus 0x squared minus x minus 3. So just remember to look out for if you need to plug in a 0 somewhere. Alright, but what if the remainder isn't 0? How would we write out that remainder? Well, the definition is if f of x is divided by some other polynomial, you're going to get the quotient plus the remainder over whatever you divided by. Right? Notice that d of x and d of x are the same. So let's try that with this whole polynomial right here. Now notice in this example, unlike anything that we've done before, this is divided by like a whole polynomial, degree 2. So I set the whole thing up. There was never any spaces for a 0. And now I'm going to go through the same process as the first example, always just figuring out how do I turn this into whatever number I get. Yeah, like for example, to turn x squared into 2x to the 4th, I'd have to multiply by 2x squared. Right? And then all of these terms get multiplied by 2x squared. So I get 2x to the 4th plus 4x cubed plus 14x squared. Go through all the same steps, change the signs and add. And notice that 2 of the terms were eliminated this time. So because I'm going to have to multiply all 3 of these things, I need 3 terms. So I'm going to bring down the plus 3x and the minus 11. All right, and that would leave me multiplying all of those terms by negative 1. So I'm going to write it right over the constant. So negative x squared plus 2x minus 7, change the signs and add. And now there's no way to turn x squared into x. So this is a remainder. So my final answer will be that this whole polynomial divided by this polynomial is 2x squared minus 1 plus the remainder over the divisor, x squared minus 2x plus 7. And I should note earlier that I forgot to call this thing a divisor, and that's why you get d of x. Okay. All right, synthetic division. This is a shortcut for dividing a polynomial by a linear factor of the form x minus c. And hopefully we remember the setup. On the outside, we're going to make a little box for our c, and then we take whatever degree we have, this 4, and I'm going to add 1 to that and create 5 little spaces. Okay, and in those spaces, I'm going to put all the coefficients, and putting zeros if something is not there. So 2x to the 4th, 0x cubed, negative 5x squared, 5x minus 2. And then this space is for c. Well, if it's of the form x minus c, what did we subtract here? X minus negative 2. All right? And so then the process, if you don't remember this from Algebra 2, just do a quick Google search on synthetic division. The first number always drops down. These numbers get multiplied. And then we just add these two numbers, negative 4. Again, multiply that by negative 2. We get 8. Add these two numbers, 3. Multiply by negative 2. All right? And we just keep going. And then this last number is our remainder. Okay, so because we divided x to the 4th by an x, now we have our quotient will start with an x cubed. And these are the coefficients of that quotient. So we have 2x cubed minus 4x squared plus 3x minus 1, and then there's no remainder. Now here's the challenge. We have 10x cubed minus 13x squared plus 5x minus 14 divided by 2x minus 3. And remember, we could just rewrite it to look like this, right? I mean, this is what's happening, this polynomial over this one. Well, to use synthetic division, it only works if you're dividing by x minus c. But here we have 2x. So how can I reduce this x? I can divide this by 2. And whatever I do to the denominator, I'll also have to do to the numerator. So now we have 5x cubed minus 13 over 2x squared plus 5 over 2x minus 7 all over x minus 3 over 2. Now use synthetic division. I'm going to encourage you to pause the video, though, and try it on your own before looking at my answer. All right, so while you were doing that, you probably had to remember how to add fractions. So what we have here is 5x squared minus x plus 4 minus 1 over x minus 3 over 2. Okay, now we can't be dividing by a fraction here. So what I'm going to do is multiply the numerator and denominator of this by 2. So I have 5x squared minus x plus 4 minus 2 over 2x minus 3. Pretty challenging problem. All right, so these notes were supposed to be about the remainder theorem and factor theorem, so let's get to it. The remainder theorem says the remainder of a polynomial f of x when divided by x minus c will be f of c. So basically, we can use synthetic division to evaluate a function at a given x. Let's try it. All right, x cubed minus 12x squared plus 48x plus 74. Evaluate for x equals 12. Notice that this time it's equals. So that's going to go in the place of c. The x cubed, so I need 4 spaces, and then just do synthetic division. Just to practice again, pause the video and see if you get the same answer as me. All right, so after doing synthetic division, this is what we should be looking at. And by the remainder theorem, whenever x equals 12, f of x is equal to 650, the remainder. That's where it gets its name. The factor theorem says a polynomial f of x has a factor x minus c if and only if f of c equals 0. So if you get a remainder of 0, you know that you have a factor of the polynomial. So here, let's try it. We're going to see if x minus 1 or x plus 3 are factors of this polynomial using synthetic division. So we'll just divide it in half and try this on your own. I mean, it's just the same thing over and over. So pause the video and then let's check. All right, on the first one, for x minus 1, we see that this is not a factor because we didn't get a remainder of 0. We got a remainder of 48. So let's check negative 3. All right, so whenever we did synthetic division with negative 3, we got a remainder of 0, which means x plus 3 is a factor. All right, and that's how we use the factor theorem, and the remainder theorem, and synthetic division, and polynomial long division. All those things all in one set of notes. Goodbye.